Nowadays, construction projects consume a lot of materials and require a lot of energy. These activities can lead to an increase in greenhouse gas emissions that has the potential to harm the Earth's natural ecosystem. Concrete and steel production have been the primary building materials. They release tons of greenhouse gases into the atmosphere every year, contributing to air pollution and climate change. Fortunately, there are some more sustainable building material that can be used for construction. The one very interesting material in Thailand is bamboo. In Thailand, bamboo is one of the most socio-economically important species. Bamboo is considered one of the most eco-friendly materials. The corresponding output is oxygen. It also has twice the compression strength of concrete and strength-to-weight ratio that is comparable to mild steel. Therefore, our group decided to research the topic of house structure design by using glue-laminated bamboo, by creating two models of two-story house, one out of bamboo and the other out of conventional materials, to compare the cost and carbon footprint in the scope of the construction process only.
For our project, we will use the software tools development for design the structure house as for following programs. First, software that we will use is Revit. We will use Revit for create the house plan and the model house to illustrate how our project will be look like. Then we will use ETABS to make the structure house and assign load into it. The software will show the load as free body diagram, shear force diagram, and bending moment diagram. Here is the flowchart that shows the steps of our project processes. We will set up the mechanical properties. Then we will create the model structure. Next, we will assign the load into the structure. After we assign the load into the structure, we will analyze the structure and get the results of shear force diagram, bending moment diagram, and axial force diagram. The results of this that we get from software, we will use it for design structural members for each houses later. First one is Tiwa house, and this one is Lux house. These are the example Revit plans our house for beam and column for each houses after we design structural members finished.
Let's talk about the building code that we used. The first one is limitations for glue-laminated timber designs. We use the National Design Specifications for Wood Constructions or NDS. And for the limitations for load or live load, we use the Thailand Building Control Act BE 2522 number 6. And for the load combination, we used minimum design loads for buildings and other structure ASCE 798. And our design philosophy is allowable stress design or ASD. Next, we will move to the destinations. Based on the NDS standards, the mechanical properties and strength value must be multiplied by applicable adjustment factor as indicated in the table. And the first factor is load duration factors. It is equal to 0.9 because we design the structure permanently. And the second factor is the temperature factor. It is equal to 1 because our structure located in Chiang Mai and the maximum temperature is 97.1 Fahrenheit. And the third factor is the wet surface factor. We separate into two conditions: the structure that designed outside and inside the covered structure. For the first condition, the factor is equal to the value on the above table, and for the second conditions, the factor is equal to the table below. And the fourth factor is shear reduction factor. All of the design structure used CVR is equal to 1 except CVR for the staircase, which is equal to 0.72, and because it is subject to the repetitive cyclic load. And next is the bearing factor. It is assumed the bearing length to be 3.93 inch or minimum value of the 1 centimeter. The bearing factor could be calculated as shown in the equations on the slide. And next is for the stability factor, like column stability factors. The calculations depends on the trial section, also the beam stability factors and volume factor. Be note that the volume factors will not be used simultaneously with the beam stability factors. The smaller value will be used. And for the requirements for the bedding members composes of the bending strength and slenderness ratio and shear strength, bearing strength, and the deflection. And for the requirements for compression members composes of the compressive strength, parallel to grain, and bearing strength, and also the slenderness ratio. For the results, these are the cross-sectional areas of beam in both houses which satisfy all of the requirements. Based on the NDS recommendation, the separate lamination should not exceed 2 inch or approximately 5 cm per lamination. And this is for column. And for the roof structure, it is composed of the purlin, rafter, hip rafter, and the king post. And next is floor design, which has a thickness of 2.5 centimeters. And eventually is a stair and tread cross-sectional area. In addition, all of these structural members are designed conservatively. The deflection model for analysis is for a single span beam, and the maximum deflections value could use the concept of superpositions to determine. And In addition, all of these structural members are designed conservatively. The deflection model for analysis is for a single span beam, and the maximum deflection value could use the concept of superpositions to determine. And the effective length is used the value in the provided table from the NDS standard.
In the part of cost estimation, we compare the cost of conventional material, which are concrete and steel, with the green material, which is laminated bamboo, that is required to construct a two-story house as described in the introduction part. The first house, Tiva house, considers the cost of all components of the house, including columns, beams, walls, slabs, roof, stair, joints, purlin, king post, rafter, and hip rafts. The cost of concrete and steel that were used to build this house is almost 1,300,000 baht. And the laminated bamboo used to construct Chiwa house after going through the design, whether the thickness or the area of the cross-section of each component of Chiwa house. The total cost of laminated bamboo materials is about 2,500,000 baht. And for the last house, we consider only columns and beam, the cost of concrete and steel that were used to build this house, and the total cost of laminated bamboo material are shown in the figure. As we can see, when the total cost of laminated bamboo used to build the white house and Lux house is compared to concrete and steel, the total cost of laminated bamboo used to build the white house and Lux house is 94% and 83.64% more expensive. But the interesting point is when we compare the carbon emission of the concrete and steel material of both houses with the laminated bamboo of Tiva house and Lux house. The carbon emission of the laminated bamboo materials had a negative carbon emission value about 17,000 kg per meter cube and about 9,500 kg per meter cube. It clearly demonstrates that in addition to being environmentally friendly, it is also a good carbon absorber in the atmosphere, which has a long-term beneficial impact.